So welcome back. So for this video, we're going to discuss about additional problems on frictional forces on flat belts. Okay, so we have here problem number 1. The maximum tension that can be developed in the cord shown is 500 newtons. If the pulley at A is free to rotate, so the pulley as A is free to rotate, and the coefficient of static friction at the fixed drum B, so you have here drum B, is at B and C. So B and C is mu S is 0.25. Determine the largest mass of the cylinder that can be lifted by the cord. So it means that we have a frictionless body on point B. So we need to determine the weight that can be carried by the maximum tension of 500 Newton. So first thing that we need to do is to draw our free body diagram. So the first part that I'm going to consider would be drum B. Okay, take note, according to the problem, the maximum tension that can be held is 500 Newton. So here we are going to draw 500 Newton. And according to the problem, it is the maximum. Therefore, from our equation, we have T2 over T1 is equivalent to E raised to mu times beta. Take note that this equation is for belts, okay, flat belts for friction. Okay, therefore, T2 is equivalent to 500. So if we are to define this part here, this is T1. Then the angle involved here would be, take note that from this point to this point, we have a contact, it is in contact with drum B. So we are going to include this. But take note, it is 1/4 of a pi, or 1/4 of a circle. Therefore, the angle here is 190 degrees. Okay? And since that is 190 degrees, the angle of inclination, if we are to draw here a free body diagram or a Cartesian plane, the angle here is 45 degrees. Therefore, the angle involved also here is equivalent to 45 degrees. Therefore, beta is equivalent to 90 plus 45 degrees, that is equivalent to 135 degrees. So we can now solve for the value of T1. So for T1, we can get it by substituting our values. T2, what is T2? 500 newtons. So 500 divided by T1. So what is T1? T1 is our unknown, is equivalent to E raised to mu. What is mu? Mu of S is 0.25. So raised to 0.25 times beta. Beta is 135 degrees. But take note, the angle here should be in radian. So we convert that to radian. We have 180 degrees is to pi. Okay, so cross multiply, we have T1 is equivalent to 500 divided by E raised to 0.25 times 135 degrees times pi over 180. So input that in your calculator. We have 500 raised to alpha E raised to 0.25 times 135 times pi over 180, and that is equivalent to 277. So T1 therefore is 277.43 kilo newtons. Okay, take note, according to our problem, free to rotate at point A. Okay, so therefore it is a frictionless pulley. So the tension here would be equivalent to the tension here. So T1 here is equivalent to T1 here. Therefore, for the free body diagram of this part, you have T1 here. So this is also T1, and this is now your weight. Okay? So, ito na yung hinahanap natin. This is what we are looking for. So, since the angle here is also 45 degrees, take note that this is 90 degrees here. The angle here is 45 degrees. Therefore, the angle also here is 45 degrees. Therefore, the total angle here is the same, to be equivalent to 135 degrees. So for this problem, we're going to use again our working equation. T2 over T1 is equivalent to E raised to mu times beta. But for this part, the T1 here is equivalent to T2 and the W here is equivalent to T1. Because T1 here should be the largest value. Take note, because the maximum tension that can be carried by this rope is 500 Newton. Then 500 Newton, we translated that to T1. Then T1 here should be the largest value. So if we are to have our equation, we have T1 over W is equivalent to E raised to mu times beta. So substituting the values, we have 277.43 divided by W, take note this is in kilonewton, is equivalent to E raised to the static friction of 0.25. So 0.25 times the beta, which is equivalent to 135 times pi over 180. So cross multiply, we can get the value of W. W is equivalent to 277.43 kilonewtons divided by the value of E, which divided by E raised to 0.25 times 135 times pi over 180. So we input that in our calculator, we can get the value of W. So 277.43, we have the value of W, which is 153.93 kilo newtons. Take note that what we are looking here, or no, that's not in kilonewton, that's in newton lang pala. Take note that what we are looking here is the mass. Okay, we know that W is equivalent to mass times gravitational acceleration. So substituting, we have 153.93 kilogram meter per second squared, that is Newton, is equivalent to mass times the gravitational acceleration, which is 9.81 meters per second squared. So meters per second squared will cancel out and we will be left with kilogram. Therefore, mass is equivalent to 15.69 kilograms. So this is the maximum weight that can be carried by this rope. Okay. Okay, so we have here problem number 2. A force P 25 is just sufficient to prevent the 20 kilogram cylinder from descending. So ibig sabihin, it is in a state of equilibrium. So what we need to do is to determine the value of P to begin lifting the cylinder. So what would be the value of P in order for the cylinder to move up? So the rope passes over rough peg with 2.5 turns. Okay, so what is our working equation? So let's start with our working equation. We have here T2 divided by T1 is equivalent to E raised to mu times beta. Okay, so what are the unknowns? Or what are the given rather? So we have here, to prevent the 20 kilogram cylinder 20 from descending. Ibig sabihin, which means the 20 kilogram cylinder is our maximum weight. So this would be our T2. So T2 is equivalent to 20 kilograms, and we need to convert that in force. So 20 kilograms times gravitational acceleration of 9.81 meter per second squared. We can convert our T2 into to force. So 20 times 9.81 is equivalent to 196. So 196.2. Excuse me. And that is in newtons. Okay. Then we have here, we are not given the mu. Take note, we are not given the mu. So unknown, we have an unknown mu, and we have an unknown of beta. But according to the problem, the rope passes over a rough peg with 2.5 turns. Okay, so beta is equivalent to 2.5 times 360 degrees, because one turn is 360 degrees, and it rotated for 2.5 turns. So 360 times 2.5, that is equivalent to 900 degrees. But take note, beta should be in radian. So we have here 900 degrees times how many angles in pi? So we have here 180 degrees for 1 pi. So divided by 180 times shift pi. Therefore, the beta here is equivalent to 5 pi. Okay, so 5 pi. Next, our T1. What should be T1? Take note, according to the problem, a force P of 25 Newton is sufficient to make it in equilibrium. So, para hindi gumalaw. So, state of rest siya. Therefore, T1 is P, and our unknown here is mu. So, if we can have mu here, then we can now solve for the value of T1, because we have T2, we have E, we know E, we have mu, and we have beta. Okay, so the first thing that we need to solve here is this the static friction. Okay, so T1, so we can now substitute here, right? So what is T2? T2 is 196.2 divided by, what is our T1? T1 is 25. So we have here 25 is equivalent to E raised to mu times beta, which is 5 pi. Input that in your calculator. Mu therefore is equivalent to 196 over 25 is equivalent to alpha E raised to alpha x times 5 pi. And mu is equivalent to, let's wait for the calculator, is equivalent to 0.1311. So 0.1311, that is for static friction. So we can now solve the value of P that will start, this cylinder to ascend. So with our working equation, we have T2 over T1 is equivalent to E raised to mu times beta. Take note, in order for this 196 kilonewton to move upward, our value for P should be bigger. Okay? Our value for P should be bigger. Therefore, our T1 here is equivalent to 196.2 newtons, because we need to have T2 to be larger. Okay? So T2 therefore is equivalent to, cross multiply T1 is equivalent to 196.2 times E raised to 0.1311 times beta of 5 pi. And that is equivalent to 196.2 times alpha E raised to 0.1311 times 5 pi. And that is equivalent to 1538.32 newtons. So this would be the needed weight or force in order to carry this, or to start ascending this 20 kilogram mass.